Hi everybody, so in this video we're just finishing off two examples of using the scalar product, and the key thing in those examples is using, at least in the first one, is using these properties that we have at the top of our screen there. So we've got the vectors a and b such that the modulus of a is 3 and the modulus of b is, or the magnitude of a is 3, the magnitude of b is 2. Given that a plus b is perpendicular to a take 2b, find the angle between the vectors a and b. So we need the dot product or the scalar product of a and b to be able to find the angle between those two. And we're told that the scalar product between a plus b and a take 2b must be 0. So if I go a plus b dotted with a take 2b, then that must equal 0 because these two are perpendicular. Now if I look above, and it's not explicitly stated there because we've got two brackets, but the idea of FOIL can be used here. So out here, if I've got a plus b dotted with c plus d, and these are all vectors, then it does stand that a dot, this is equal to a dot c plus a dot d plus b dot c plus b dot d, FOIL. First outers, inners, lasts. So using that idea, the first thing I'm going to get is I'm going to get a dot a. Then I'm going to get a dotted with minus 2b. So I've got plus a dotted with minus 2b. And then I'm going to get b dotted with a. And then I'm going to get b dotted with minus 2b. Now, and that must equal 0. First of all, if I have a look at my properties, the second one tells me that a dot a is the modulus of a squared, and we know the modulus of a. So we'll just write that in straight away, the modulus of a squared. Now, a dotted with minus 2b, well, if I look at the last one down here, if lambda is a real number, and it's beside one of the vectors like it is here, beside a, and here it's beside b, then it's fine to bring it out the front. So I can bring it out the front and have minus 2a dot b. B dotted with a is the same as a dotted with b. That's by the first one here. So I'll write that as plus a dotted with b. And again, we've got this idea of the minus sitting down here, so we'll say that's minus 2b dotted with b. Okay, now the modulus of a squared, well, the modulus of a is 3, so that's 3 squared. Minus 2a dot b plus a dot b is minus a dot b, collecting like terms, and minus 2b dot b is minus 2 modulus of b squared. Modulus of b is 2, so I'll have 9 take a dot b, take 2 times 2 squared, or 2 times 4, which is 2 times 4 is 8. Maybe I'll add an extra line. So that's 2 times 2 squared. So it's 9 take a dot b, take 8. So 9 take 8 is 1. So it'll be 1 take a dot b. And then moving the a dot b to the other side gives me that a dot b is equal to 1. Now, cos theta is equal to a dot b divided by the modulus of a times by the modulus of b. Now, where theta is the angle between a and b. So then cos theta is 1 on 3 times 2, which is 1 on 6. So theta is equal to, well, it'll just be the cos inverse of 1 on 6, and depending on whether our calculator is set in radians or degrees will depend on the answer we get. And the answer we do get is that it is 1.40 radians, and I indicate that it's radians by not giving it any units, so that's fine for radians. So 1.40 is the angle between A and B. Okay. Then the last example, vectors A and B are given in component form, so these are just two-dimensional vectors where lambda and mu are real numbers. Find the relationship between lambda and mu given that the two vectors are perpendicular. Okay, this is a standard sort of question that might come up in the exam fairly early on in a paper. They consider this one of the easier ones, so it's worth getting comfortable with ones like this. So we've got 2 mu, take 5 lambda equals 0. Now they want the relationship between lambda and mu given that they're perpendicular. Well, we've got a relationship. I mean, where do they want us to stop? Well, it's a bit ambiguous. We could say that or that. I don't know, it really depends on what we need in the second part. So we'll just leave it like that for the moment. Find the two possible vectors A in part A, given that the magnitude of B is 13. Well, we need to be able to find A, we need to be able to know what lambda is. And to know what lambda is, well, we can find out what mu is, because we know the magnitude of B. So the magnitude of B is just the square root of mu squared plus minus 5 squared. So that's equal to mu squared plus 25, square root of, and that's equal to 13. Okay, so then if that's, I'll square both sides, so 169 will be equal to mu squared plus 25. And then if I do 169 take 25, that's 144 is equal to mu squared. So mu is equal to plus or minus 12. And this is where our two possible vectors for A is coming in. Now, okay, the one I need is I need lambda in terms of mu. So lambda is equal to 2/5 mu. Because I need to be able to find lambda if I know mu. So, if mu is equal to positive 12, lambda is equal to 24 on 5. If mu is equal to negative 12, lambda is equal to negative 24 on 5. And so then the two possible vectors, well, we've got A is equal to, now the initial component is, or the x component is 2. So it'll be 2, 24 on 5. And here it would be 2, negative 24 on 5. And that wraps up this question. So just the last thing I want to make mention of is these are the questions from 9E based on Scalar Product, and it is worth doing these and not skipping any of them, because there are questions that are, well, it's a concept that gets probably tested a fair bit in an exam, and you want to be confident at it. And so yeah, make sure you do those questions, because it's really going to help you come test and exam time.